This is my pre-algebra course. Today we're going to review for test number 4. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As usual, to prepare for the test, we're going to do 2 practice exams. You're going to do one with me right now, and I'm going to give you one for homework. So let's get started. Graph the following equations. So we're going to graph x equals 1, and that would just be a point. So let's go ahead and mark that point, and that's it. So you try on part B, x equals -2. Alright, so if you wrote your dot here, that's correct. So these are pretty easy. Alright, solve. We have an equation with decimals. So there are variables on both sides. So we need to get all the variables on the same side, but first we need to simplify this expression because we can combine those x's. Now whenever you have an equation with decimals, you're allowed to use your calculator. So 2.3 minus 5.6 is -3.3. So -3.3x, and there's nothing else that we can simplify. So now we're going to have to perform an operation on both sides of the equation to get the variables on one side of the equation. So in order to keep the variable terms positive, I'm going to add 3.3x to both sides. So because I'm going to do an operation on both sides of the equation, I have to rewrite the equation. And I'm going to try to move it over a little bit so I have enough room here. I should probably put a divider. And try to stay nice and neat. So again, you can get out your calculator, and it looks like that's going to be 12x. So we have the variables on one side of the equation now. So now we have to put the normal numbers, the regular numbers that don't have variables, on the other side of the equation. So we're going to rewrite because we're about to perform an operation on both sides of the equation. And we get -5 equals 12x. And we need to rewrite again. Whoops, sorry. Because we're going to perform one more operation on both sides of the equation. And of course we can just leave our answer as a fraction. So if you got -5/12, good job. I did mention that you should be trying these on your own before we do them together. I guess you don't have to, but if you have an idea of how to do the problem, you should go ahead and try it on your own before watching me do it. Alright, if 49 is increased to 51, what is the percent increase? Now we need to use the percent increase formula. The new number after the increase or decrease is equal to the first number, the original number, minus the original number times the percent written as a decimal. That's what R means, the percent written as a decimal. But again, remember, the percent must always be written as a decimal in any equation. Alright, so the new number is 51. That's the number after the increase. And the original number is 49. And we're looking for R, because once we find R, we can then change it back to a percent. And that's going to be the answer. So this is a two-step equation. So we're going to, I'm going to need to move this over a little bit. So we have enough room to form an operation on both sides of the equation. So I have to perform an operation on both sides of the equation, so I have to rewrite the equation. And the only time that I'm going to allow you to violate that rule is when you have an equation with parentheses, because those equations are the longest versions of these types of problems. So we subtract 49 from both sides, and then we get negative 49r equals 2. And I just noticed that I put a negative there. That should be positive. And the reason it's positive is because it's an increase. All right, so we're going to rewrite the equation again to perform the second step. Again, we have to preserve the result of our previous step. So now r is equal to whatever 2 divided by 49 is. So let's do that on the calculator. 2 divided by 49 is a decimal that just keeps going on and on and on and on. So notice here it says round to the nearest hundredth of a percent. So we're going to round, but first, before we round, we have to change it to a percent. It says round to the nearest hundredth of a percent. Now if I write this decimal out, I'm going to write a few terms here, actually about 4 or 5 terms. R is equal to 0.04 0816, so on and so forth. So I should say approximately equal to. It's not exactly equal to. And so if I round to the nearest hundredth, the hundredth place would be here. But if I round and make my answer 0.04, that's going to be wrong. When it says round to the nearest hundredth of a percent, that means you have to change it to a percent first, then you find the hundredth place. So we're going to change it to a percent, 4.0816%. And then at that point, you can then round off to the nearest hundredth. So the hundredth in this, after you change it to a decimal, is here. So if you round it off, you get 4.08%, and that's our final answer. So if you don't round correctly, you're going to get a point taken off. So that looks correct. So again, if it says nearest hundredth of a percent, or tenth of a percent, or thousandth of a percent, you have to change the decimal to a percent first, then find that place. Again, the hundredth place is here when it's a decimal, but when you change it to a percent, the hundredth place changes because it's a hundredth of a percent, not just a hundredth. So because it's a hundredth of a percent, it's technically not really a hundredth. It's actually 1/10,000th of the actual number. All right, so on to the next problem. Number 4, we have a very large equation. So we have there's 2 things to consider. First of all, we have decimals, which means that we can use our calculator, and we also have parentheses, which means that we can we don't have to show every single step. We just have to show the result after performing the step. So let me get my calculator out. 2.8 times 3, because we're using distribution. The first thing that we need to do when we have an equation with parentheses is get rid of the parentheses. So we're going to multiply negative 2.8 times 3z, and then we're going to multiply negative 2.8 times 2. That's the distribution rule, or the distributive rule. And then we're going to multiply 3 times z and 3 times negative 4. So we're going to use the distribution rule twice. All right, so negative 2.8 times 3z is negative 8.4z. And again, you can use your calculator there. And 2 times 2.8 is 5.6. So that would be negative 5.6. And 3 times z is 3z, and 3 times negative 4 is negative 12. So that was pretty easy. That wasn't too bad. We got rid of those parentheses. Again, you can use your calculator for the decimal part. I'm just double checking that everything looks right. So now we're going to simplify. Negative 8.4z plus 3z is going to be negative 5.4z, and negative 5.6 plus, negative 5.6 plus negative 12 is negative 17.6, and 3.1z minus 2z is 1.1z. So just double checking that. So now we're going to perform two operations at the same time, because this is the point where you'd usually rewrite the equation, because we have to now perform operations on both sides of the equation. Up till now, we have not performed an operation on both sides of the equation. But now we need to do that. So normally we would rewrite to preserve the result of our previous step, and we would just continue. But in this case, I'm just going to allow you to not have to show that. So we're going to add 5.4z to both sides, and we're just going to write the result after we do that. So we added 5.4z to both sides, and now we're going to divide both sides by 6.5. But again, I don't have to show that. I do have to get my calculator. 17.6 divided by 6.5 is a decimal that goes on forever. So we're going to have to write approximately equal to, and it's approximately equal to 2.70769. 70769. And it says here, round off to the nearest thousandth. So this is not a percent, so we don't have to worry about changing it to a percent first. So the nearest thousandth place is here. So we look to the 6, and the 6 tells us to round the 7 up. The yellow number tells us to round the yellow number up. So z is approximately equal to, we have to keep our approximate sign, 2.708. So the yellow number goes up 1, and all the numbers to the right of the yellow number, they disappear. Find the algebraic solutions and the graphical solutions of the following inequalities. So first we just pretend that this is an equal sign, just like a normal equation, and we go ahead and just solve it. So this equation doesn't have parentheses, so I'm going to require you to show every single step. So we're going to rewrite, add 1 to both sides. This is a two-step equation. And we're going to perform an operation on both sides, so we have to rewrite again. And we're going to multiply both sides by 5. And we're left with x is less than 35. So that's the algebraic solution. But they want us to find the graphical solution also. Please understand that when you take the test, you have to find the algebraic solution of these inequalities and the graphical solution, because it's very common for teachers to ask for both. So we're going to write our number line, and we have 35, so we're going to need maybe intervals of 10. So 10, 20, 30, 40, 50, so on and so forth. And you don't have to label each one of these divisions. Don't waste your time labeling every one. You can just skip. All right, so x is less than 35, and we need an open circle because it's not less than or equal to, it's just less than. So we need our open circle here. And remember, x is the shaded part, and it tells us x is less than 35. The variable is always the shaded part. So the variable here, x, is less than 35, so the shaded part needs to be less than 35. So if you got that answer, good job. All right, on to the next one. Our first step is to simplify. Now we're going to going to perform an operation on both sides of the equation. So we have to rewrite that equation. And again, we're going to perform an operation on both sides of the equation, so we have to rewrite. And we have y is less than or equal to negative 6/7. So that's the algebraic solution. All right, so now that's the algebraic solution. So now we have to do the graphical solution. I'm just going to write 1 and negative 1, and then negative 6/7. Actually, that's not going to work. We could do it a better way. Y is less than negative 6/7, so I'm going to write 0 over here. And 1, 2. Just try to make sure that your divisions are evenly spaced. And y is less than or equal to negative 6/7. So negative 6/7 is about here. And I'm gonna draw a filled in dot because it's less than or equal to. So again, y is the shaded part. This tells us that y is less than or equal to negative 6/7. So the shaded part must be less than. So we're going to shade in this part. So remember, you might have to shade this part. It just depends on what the inequality looks like. All right, so on to number 7. We have another inequality. So first step is to simplify. 5z minus 3z is 2z. And then we're going to perform an operation on both sides of the equation, so we need to rewrite the equation. Subtract 2z from both sides. And now we're going to perform the last step, so we need to rewrite again. Divide both sides by negative 4. Now here's the part where you really need to pay attention. Remember, if you multiply or divide both sides of an inequality by a negative number, you have to flip that inequality. So I have to take that inequality. It's not correct anymore. Because I divided by negative 4, it's not correct. So I have to actually erase that. And I have to flip it immediately. As soon as you divide by that negative, that statement becomes incorrect. So you have to flip that. And now we have z is greater than negative 3/4. So that's the algebraic solution. So you must remember to flip that inequality if you multiply or divide both sides of the equation by a negative. Again, you must flip the inequality if you multiply or divide both sides of the inequality by a negative. I think I just said equation. I meant inequality. So let's go ahead and graph that. So again, I'm just going to put 1 and negative 1. Negative 3/4 is about here. And it must be an open dot because it's not equal to, it's just greater than. And again, z is the shaded part. So is the shaded part here to the left or is it to the right? That's the tricky part. So it tells us z, the shaded part. Again, the variable is always the shaded part. You must understand that. The variable z is the shaded part. Is the shaded part here or here? Well, z is greater than. It's greater than, so that means the shaded part is greater than. So you fill in the shaded part. I mean, fill in that shade to the right of that circle. All right. So on to number 8. What percent of 603 is 900? So this is a basic finding the percent of a number problem. So if you want to know if you want to find the percent of a number, you take the number and you multiply it by the decimal form of the percent, which is what we don't know, and that gives you the percent of the number. What percent, or find a certain percent of 603, and that's 900. So remember, one thing that can help you, because a lot of students are going to set the problem up and they're going to write the wrong order. This is incorrect. So one way that you can avoid that is by understanding that the is word is always an equal sign. So 900 is to the right of the equal sign, and the unknown, what percent, and this number is to the left. Because the wording on these problems can be confusing. You're going to see a lot of different wordings. You can see it in the reverse direction. 900 is what percent of 603? All right, so you can see this is a one-step equation. So we just have to perform one operation on both sides of the equation. So we have to rewrite that equation. Divide both sides by 603. And x is equal to 900 divided by 603. So let's get the calculator for that. 900 divided by 603. And we're going to get a number with a lot of digits. So remember, x is a percent. So remember, it tells us to round off to the nearest tenth of a percent. So that means you have to change it to a percent first. And by the way, I need to change this to a approximately equal to sign. So let's change it to a percent first. So it becomes 149.2537%. And again, to change, I didn't mention that, to change from a decimal to a percent, you just move the decimal 2 places to the right. We learned that in the last course. So now we have 149.2537%. So now, at this point, now we find the tenth place because it's a tenth of a percent. It's not an actual tenth. This is an actual tenth. We don't want to round off to an actual tenth. We want to round off to a tenth of a percent. So that would be here. That would be the 2. So we look to the number to the right, and 5 tells us to round up. So our final answer is, and by the way, that shouldn't be x equals. Our final answer is 149.3%. So that the yellow number goes up 1, and all the numbers to the right of that yellow number, they become 0. And because they're ending zeros, they just disappear. All right, number 9, find the area of the rectangle below. So we have algebraic expressions for the width and the length of this rectangle. So whenever you use a formula that we learned, I require you to write the formula, and the formula is A equals LW. This is one of the formulas on your sheet with all the geometric formulas. So now we just rewrite, but we plug in what we know and solve for what we don't know. So actually, we don't really need to write the A over again. Actually, we probably should. So L is 5.1 x squared y, and W is 6.7 x cubed y squared. Now, we didn't need parentheses on both of these, but it helps us understand, helps us separate the length and the width. All right, so now we can multiply. We need the calculator for that. 5.1 times 6.7 is 34.17. So we multiply the numbers first. And x to the second power times x to the third power is x to the fifth power. You just add those powers, and y times y to the second is y to the third. So you got 1y, and you're multiplying 2y, so that's a total of 3 y's that you're multiplying. So we got that answer. Good job. All right, find the perimeter of the parallelogram below. So you should know what perimeter is. And you should know what area of a rectangle is. Those are just things that you have to remember and never forget for the rest of your life. So we have to add all these fractions. So P for perimeter equals 13z over 6 plus 13z over 6. And we can just add them all up. So here we have a common denominator, so 13 plus 13 is 26. And here we have a common denominator, so 3z plus 3z is 6z. Now before we get a common denominator, we should reduce these fractions, because it'll make the numbers easier for us. So we can divide both sides of this fraction by 2 to get 13z over 3. And divide both sides of this fraction by 2 to get 3z over 2. So that'll make things easier. So now we're going to need to get a common denominator. And the common denominator is going to be 6. So multiply both sides of the first fraction by 2 to get 26z over 6. So we just went in the backwards direction. And multiply both sides of the second fraction by 3 to get 9z over 6. So now we can add those up, and the final answer is going to be, let's see, 26z plus 9z is 35z. And then we just write over 6. So if you got that answer, good job. We cannot reduce that. All right, find the surface area of a sphere with radius 2x squared y cubed over 5z. Surface area of a sphere. So that's one of the formulas on our geometric formula sheet. So surface area is equal to 4 pi r squared. So again, you have to write that formula first. You must write the formula to show the tool that you're using. So we're just going to plug in the radius. So now we just have to simplify. So what does raising to the second power mean? Well, it means you're just taking whatever is in the whatever's the base is. This is called the base, and you're just multiplying it by itself. And I don't mean geometric base. I mean it's just that's what they call whatever you're raising to a power. They call it the base. So we're just multiplying that by itself. So now we're just, as you can see, we're just multiplying fractions. So when you multiply fractions, you just multiply the numerators straight across. So 2 times 2 is 4. X squared times x squared is x to the 4th. Y to the 3rd times y to the 3rd is y to the 6th. And the bottom, 5 times 5 is 25, and z times z is z to the 2nd power. So now we can consider this 4 pi to be 4 pi over 1. And we can just combine. So we're going to multiply the denominators. That would just be 25z squared. Anything multiplied by 1 just stays the same. And then 4 times 4 is 16. And it tells us, actually it doesn't tell us, but I should have clarified that. Keep pi as a factor. So we're going to keep pi in our answer. That's all that means, to keep pi in your answer. 4 times 4 is 16. Then we just keep pi there as a factor. And then rewrite the variable expressions. So that is the answer for number 11. All right, number 12, find the average of the following numbers. So remember, to find the average, you just add up all the numbers and divide by how many numbers there are. So let's write mean, because mean is the same thing as average. And remember, we showed division with the fraction line, so we're going to divide by, let's see. Well, first of all, let's go ahead and add those numbers. So 5x, whoops. So 5x minus 2x, and so on and so forth. Then we can put a divider. So let's double check that I got all those numbers right. 5x minus 2x plus 4x plus 3x plus 2x plus 5x minus 4x minus x. That looks right. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we're going to divide by 8. So again, that's the definition of average, and average means the same thing as mean. Whenever you have a fraction expression, you always have to simplify the numerator and the denominator first. So we're going to have to go ahead and add all those numbers up. So 5x minus 2x is 3x, 3x plus 4x is 7x, 7x plus 3x is 10x, 10x plus 2x is 12x, 12x plus 5x is 17x, 17x minus 4x is 13x, 13x minus x is 12x. So equals 12x over 8, and we can simplify that a little bit. Divide both sides by 4, and you get 3x over 2. So if you got 3x over 2 for the average there, good job. All right, so 13 says evaluate your answer for problem number 11. That's this problem up here. If y equals 1, x equals 2, and z equals 3. So our answer to number 11, as you can see, is right here. So we're going to evaluate that answer. So a is equal to 16 pi, and then we have to plug in 2 for x. So 2 to the 4th power, and then 1 for y, so 1 to the 6th power. And 25 times z is 3, they tell us. So again, all I did was just plug in these numbers into this formula. That's what it means to evaluate. So now we just have to simplify. So 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's going to be 16. And then 1 to the 6th power is 1 times 1 times 1 times 1 times 1. And when you just multiply 1 by itself a bunch of times, you're just going to get 1. And then 3 to the 2nd power is 9. So again, I had to simplify the numerator, then simplify the denominator. Do not divide these until you simplify the numerator and the denominator first. Also, we had to follow order of operations. Notice that I did the powers first. PEMDAS tells us to do the powers first. So now we do multiplication. So 16 times 16, we can get the calculator out for that, or you can do it off to the side. Actually, this is not a decimal problem, so we should probably go ahead and just do it off to the side. 6 times 6 is 36, carry the 3. 6 times 1 is 6, plus 3 is 9. Put a placeholder. 1 times 6 is 6, 1 times 1 is 1. Add those up, and you get 256. So we have 256 pi, and then 25 times 9, that would be 225, I believe. And there's no common factors because you have 3's down here and 5's down there, but you only have 2's up here, so there's no common factors. But we're going to keep that pi as a factor. I should have clarified that in this problem, to keep pi as a factor. In most of the problems on the test, I'm going to tell you to keep pi as a factor. All right, on to part B. Find the volume of a sphere with radius 1 inch. Keep pi as a factor in your answer. So let's get out our volume formula. Volume of a sphere is 4 pi r to the 3rd power over 3. So again, you have to write that formula. You have to show the formula that you're using. And the radius is 1 inch, so we just plug in 1. This is just an evaluation problem. And then volume equals, and then 1 to the third power is just 1, so we have 4 pi times 1 over 3. And of course 1 times 4 pi would just be 4 pi. And so we're left with 4 pi over 3. But we're given a unit here. It says inches. So we're going to write IN for inches. But it's a volume, so it's going to be inches cubed. So again, that was just an evaluation problem. You just plug in 1 and evaluate. All right. So on to number 14. The sum of 4 consecutive odd integers is 168. Identify these integers. So we're going to let the first integer, the smallest integer, be x. And then the second integer would be x plus 2. And the third, and I should probably explain what's going on here if you forgot. First of all, they're odd, so that means 1, 3, 5, 7, 9, 11, 13. Those are odd numbers. And it says they're consecutive, meaning they're right next to each other. So for example, 57, 59, 61, these are consecutive odd integers because they're right next to each other if you list them, and they're odd. So if the first, we're going to let the first integer be x, so you just add 2 to get the next odd integer, the next consecutive odd integer. All right, and then the fourth is going to be x plus 6. All right, so now we make an equation. So they tell us that the sum of all those numbers is 168. So we're going to go ahead and add those up. And this is where the algebra comes in. Add all those up and we get 168. So now we're just going to simplify. So we can just get rid of those parentheses. And x plus x is 2x, plus x is 3x, plus x is 4x. So we have 4 x's. And then 2 plus 4 plus 6 is 12. And that just becomes a two-step equation. So we're going to have to rewrite the equation. Subtract 12 from both sides. And we get 156 and 4x. So we have to rewrite that equation. I'm going to move these up a little bit. Give us some room. So rewrite that equation. Divide both sides by 4. And 156 divided by 4. I'm just going to use the calculator for that. That's 39. So x is equal to 39. So that means the smallest of those odd integers is 39. So if the smallest is 39, then you just add 2 to get the next integer, and add 2 again, and add 2 again. So that is our answer, 39, 41, 43, and 45. All right, the size of Casey's hamburgers decreased by 21%. The new volume is 2.7 ounces. What was the volume before the decrease? Round to the nearest tenth. So this is a percent change problem, so we need to get our formula out. The new number is equal to the first number, and this is decrease, so we have to do minus FR. So that's our percent change formula for decrease. Again, if it were an increase, we put a plus sign. So now, let me move this over a little bit. We'll just plug in what we know and solve for what we don't know. Find what we don't know. So the new number is 2.7. 2.7 ounces. And the first number, the original number, we don't know. But we do know that the rate is 21%, but we have to write it as a decimal. So that would be 0.21. Now in this case, we're changing from a percent to a decimal. We're going the opposite direction. So the decimal, it's not visible in that number. But remember, when you have a whole number, 21 is a whole number, the decimal is always directly to the right of the number of the number in the ones place. So that would be right here. So you have to move it 2 places in the opposite direction to the left. So it becomes 0.21. So again, that's all review from the previous course. All right, so I'm just going to move that 0.21 in front of the F because it's traditional to write it to the left of the F. And these are what we call like terms, so we can just combine those. There's no coefficient here, but it's just assumed to be 1. 1F minus 0.21F would be 0.79F. You can use your calculator for that, 1 minus 0.21. So now we're going to have to perform an operation on both sides of the equation. So we rewrite the equation and divide both sides by 0.79. And you're allowed to use the calculator on this part. 2.7 divided by 0.79. The decimal is just going to go on forever. So F is approximately equal to 3.4177. And it tells us round off to the nearest tenth. Now, F is not a percent, it's just a number. So we don't have to change it to a percent first. So the nearest tenth, the tenth place will be here, and the blue number is going to tell us whether or not to round up or down. So the blue number tells us to round down, so we keep the 4. So we just write 3.4, and all these numbers become 0, but because they're zeros to the right of the decimal that are ending zeros, they just disappear. We don't even have to write them. So 3.4 is approximately equal to that first number. But I'm going to get a point taken off unless I write the units. So the units are ounces, and we write ounces with OZ. That's the abbreviation for ounces. All right, so Casey's hamburgers were 3.4 ounces, and then they were decreased to 2.7 ounces. If 27% of a number is 0.675, what is the number? So again, this is just a basic percent problem, finding the percent of a number. This is not a percent change problem. It's just a basic finding the percent of a number problem. If 27% of a number, so 27%, so we're finding the percent of a number, we have to change that percent to a decimal. Then we multiply it by whatever the number is, and that gives us the percent of that number. So again, you always have to change the percent to a decimal when you use it in an equation. And you take that decimal form of the percent and you multiply it by the number, and that gives you the percent of the number. So again, the is sign is an equal sign. So the number that we're looking for and the percent, they have to go on one side of the equation, and this number goes on the other side. Don't confuse that. Don't mix that up. So this is a one-step equation, so we can go ahead and rewrite. Perform our operation on both sides of the equation. And we're going to need our calculator for that. So 0.27, or actually 0.675 divided by 0.27 is 2.5. So x is equal to 2.5. That's the number that we're looking for. All right, number 17, find the perimeter of the triangle below. So again, perimeter is just something that you need to remember. You're not allowed to forget perimeter. In the same way, you're not allowed to forget the area of a triangle or the area of a rectangle or the area of a square. These are basic things. If you don't know these things, when you're finished with your math course, that means you're not learning what you need to learn. All right, so perimeter is equal to the sum of all the sides of the triangle. And add those up and you get 7y. So perimeter is equal to 7y. So that was an easy one. You deposit money in a new savings account. The account pays 0.8% simple interest annually. That means once every year. After 5 years, the account grows to $31.20. How much money did you deposit? Assume no additional deposit. So it looks like this is going to be a three-step equation. Let's see. So let's write our formula that we're going to use. The amount of money in an account is equal to the amount that you deposit plus the amount you deposit times the rate written as a decimal, the percent written as a decimal, times the amount of time it's in the account. So now we just have to plug in what we know and solve for what we don't know. So we know that the amount of money in the account, A, is 31.2, and we don't have to write that 0 because it's an ending 0 to the right of the decimal. The principal, the money that we deposited, we don't know, so we're just going to have to keep the P there. R is going to be, we know that the rate is 0.8%, but we have to write it as a decimal. So remember, when you change a percent to a decimal, you take that decimal and you move it 2 places to the left. So that's going to be 0.008. And then the amount of time is 5 years. And we can put the 5 in parentheses, but we can also just leave it. We don't have to put that in parentheses. All right, so 0.008 times 5, I'm doing in my calculator, is 0.04. So this is the first step. We're just simplifying, and I'm going to write that 0.04 in front of the P. To the left of the P, it's just traditional to do it that way. Again, you can do that because of the commutative rule of multiplication. So now these are like terms, so we can just add those up. So P plus 0.04p is, so that's 1p plus 0.04p is 1.04p. It's very easy. But you can use your calculator for that too. 1 plus 0.04 is 1.04. So now we're going to have to rewrite the equation because we're going to perform an operation on both sides of the equation. In fact, this is the first point in this problem where we're going to perform an operation on both sides of the equation. Now we're going to need our calculator. So P is, let's see what that will be, 31.2 divided by 1.04 is equal to 30. So the principal is going to be exactly $30. That's the amount of money you deposited. All right, on to number 19. I should have directions on this problem. The directions are solve. All right, so as an equation with decimals, so we have to simplify first. Negative 4y plus 8.8y is negative 3.2y. Again, you can use a calculator for that if you want. And now we have to get the variables on one side of the equation. So we're going to have to rewrite the equation, and I know that I'm going to not have enough room here, so I'm going to have to move this over. And add 3.2y to both sides. And I think that would be 1.4y. Now we're going to perform the second step. Or not the second step, but the second operation on both sides of the equation. So we're going to divide both sides by 1.4. Again, I had to rewrite. Whenever you perform an operation on both sides of the equation, rewrite. So now we can get our calculator. 5 divided by 1.4 is a decimal that goes on forever. So I forgot to say round to the nearest tenth. So y is approximately equal to 3.57, and it just keeps going on and on. This is the 10th place. The 7 tells us to round up, so the 5 is going to go up to 6. And all the other numbers are going to go to 0. So 3.6. So if you got that answer, good job. All right. Number 20, graph the following equations. Show all work and identify the points you use to graph the equations. Label your graphs properly. So I'm going to require you to actually draw your axes. So I'm drawing my axes now, and you must label your axes. Please understand, you must label the axes. Teachers just love to take off points for not labeling your axes. This is usually called the x-axis. This is called the y-axis. The horizontal is x, the vertical is y. And let's see, so now we're going to have to, in order to graph that equation, that's a linear equation, so we're going to have to find 2 points to graph the equation, and then we just connect the dots. So the first point, we're going to plug in, and you don't have to draw a table if you don't want to, but I'm just going to go ahead and draw one. So the first point, I'm going to let x is solved for, x is by itself, so it's best to find the other number first. So we're going to plug in y. Remember, 0 is always a good choice, or usually a good choice, so y is going to be 0. So x is equal to 0 plus 2. I'm plugging 0 into that equation up here. So y is 0. And then x is equal to 0 plus 2 is 2. So I'm going to put 2 for x, because x must be 2. Then I'm going to find one more point. We just need one more point. So now let's let y equal 1. So I'm going to put 1 in our table. Therefore, x is equal to 1 plus 2, which is 3. And by the way, I'm going to write these points also. So x is 2, y is 0, x is 3, y is 1. So now we have our points. So at this juncture, we can find our scale. So I'm going to make 4 the biggest numbers and the smallest numbers on the graph. It's hard to make your scale before you actually find your points. You want to find your points first, then make your scale, because your points are going to determine what your scale is. You don't want to go off the graph, and you don't want the scale to be too small or too large, that is, because then it's going to be hard to graph the points. So 2, 0 would be here, and 3, 1 would be here. So then we can just connect the dots and make sure your line is roughly straight. It doesn't have to be perfect, but if you draw your line and it goes off like that, that's obviously not appropriate. You need to make it roughly linear. So again, the reason we use this method is because we know it's a linear equation. We're not going to do any kind of curves in this class. They're all going to be linear equations. In fact, in the next course, you're not going to be doing curves either. In this course and the next course, it's just linear equations. All right. So at this point, we have the points. We don't really need to write them, but if you want to, you can go ahead and write on the graph what the points are. That's another way to do it, but you have to identify the points somehow. You can either you can do it this way by writing the points next to the dots, or writing the ordered pairs next to the dots. You can use a table, or you can write them here. But you have to show those points. And regardless of where you put the points, here, here, or here, you have to show the work that you did to find those points. So there's a lot to think about in those graphing problems. All right, same thing for problem 21. So I'm going to draw my axes, and I got to label them. And then we need 2 points as usual. So the first point, let's see, y is isolated, so it's best to plug in the other number first. It just makes it easier to do the math. So I'm going to try 0 for x. So y is equal to 1 minus 0 over 2. 0 over 2 is just 0, and therefore y is 1. So the point is 0, 1. And now I'm going to try, now we have a fraction here, so you got to be careful. If you plug in 1 for x, then we get a fraction. We want to stay away from the fraction. So let's try plugging in 2 for x. You have to choose wisely. 1 minus 2 over 2. 2 over 2 is 1, so we get y is equal to 0. So the point is 2, 0. So now we have our points. And I'm going to just make this 2. And again, you don't have to label all of your points. Just label enough to where we get a feel for the scale. And you don't have to get a ruler either. It's not important to be that exact. So 2, 0 is here. And we have 0, 1, which is here. And then we just connect the dots. And there you go. So there's our graph. So again, you can write the points here if you want. So if you got that graph, good job. All right, 22. Again, we're going to draw our axes. I'm going to require you to draw the axes. And be sure to label those. And as usual, to graph the line, we just need 2 points. We can find an infinite number of points on the line, but we just need 2 points. So in this case, neither x nor y are by themselves on one side of the equation. So in this case, we're gonna we might need some basic algebra, but I think we can actually avoid the algebra if we choose wisely. So let's choose 0 for x. Then we get negative 0 plus y is equal to 1, and negative 0 is just 0. And then 0 plus y is y. So we see that if x is 0, y is 1. So the point is 0, 1. Now let's make y equal to 0. So then we'd have negative x plus 0 is equal to 1. Negative x is equal to 1. And remember, if you have a negative x, that means negative 1 times x. So what you want to do is divide both sides by negative 1. And the negative 1 cancels out on the left side of the equation, and you have negative 1. So if x is if y is 0, x is negative 1. So now we're ready to make our scale. We can just, I'm just going to make one division here for 1. And our first point, 0, 1, is here. Second point is negative 1, 0. 0, 1. That'll be here. Negative 1, 0. And just connect the dots. And it's important to connect your dots first before you draw those points. If you want to draw the points next to or draw the ordered pairs next to the dots, or else your line might run into the ordered pairs. All right. So number 23 is going to be even more difficult, as you'll see, because we're going to have to definitely perform some algebra on number 23. So again, let's draw our axes. And it doesn't have to be perfect, but just try to draw them as straight as possible without using a ruler. So as usual, we're going to need 2 points. So now there's really no way to avoid fractions on this problem. Well, actually, we might be able to avoid them, but it would take some. It would take a lot of trial and error. So in this case, we're just going to say that that x is equal to 0 and y is equal to 0. So let's let x equal 0. Negative 3 times 0 is 0. And we're left with 2y is equal to 2. So we're going to divide both sides by 2. And we get y is equal to 1. So if x is 0, y is 1. That's the first point. Now we're going to let y equal 0. Two times 0 is 0. And we get negative 3x is equal to 2. Divide both sides by negative 3. And I'm not rewriting the equation just because we can already see that it's up here. We just have an extra 0 there, that's all. X is equal to negative 2/3. So if y is 0, x is equal to negative 2/3. Actually, that was the opposite direction. That was not correct. Actually, wait a second. I'm fooling myself. There we go. I said it backwards and wrote it correctly. If y is 0, x is equal to negative 2/3. And if x is 0, y is equal to 1. All right, so now let's plot the point, or both points. I can just use 1. 0, 1 is here. And negative 2/3, 0 is here, approximately. Connect the dots. And there you go. So again, you can show the points on the graph if you want, but you have to show them somewhere. So that was a more difficult problem there. All right, on to 24. Graph the following inequalities, show all work, and identify the points you use to graph the equations. Label your graphs properly. This should not be equations, that should be inequalities. I meant to write inequalities there. All right, so this is the same problem that we just did, except we're going to be graphing inequalities, but it's pretty much the same process with a few minor differences. So we're going to graph 2 points as usual. And again, I'm using a table, but you don't have to use a table. So there's no variable that's solved for on this equation or inequality. Again, technically it's not an equation, it's an inequality. So I'm just going to let y equal 0. Negative 2 times 0 is 0, so we just have negative 4 minus 0 is less than or equal to x plus 1. Negative 4 minus 0 is just negative 4. And then I'm going to subtract both sides from the, or subtract 1 from both sides of the equation. And I get x is less than negative 5. And by the way, you can just write equal signs here. You don't have to write inequality signs because we don't really need the inequality. So I'm just going to actually just change these to equal signs, because the purpose here is simply to find points. To find points on the line. So negative 5, 0. And for the second point, I'm going to put a divider here. I'm going to let x equal 0 for the second point. So we have negative 4 minus 2y, and I'm going to switch that to an equal sign. Negative 4 minus 2y is equal to 1. And then we're going to, I should probably just rewrite that equation. We're going to add 4 to both sides of the equation. And we get negative 2y is equal to 5, so we're going to have to rewrite that equation. Again, I'm going to require you to rewrite the equation every time you perform an operation on both sides of the equation, except when you have an equation with parentheses, where you have to use the distribution rule. So if x is equal to 0, y is equal to negative 5 halves. So those are our 2 points. All right, so now we're ready to graph those points. So I'm just going to make 5 the biggest point here. So the halfway between 5 would be 2.5. That might be kind of confusing if you don't realize that half of 5 is 2.5. You can use a different scale if you want to. So negative 5, 0 would be here, and 0, negative 5 halves. So negative 5 halves is just negative 2.5. That's one way to think of it. So negative 2.5 is, that would be right here. So there's a number of different ways to do this. So if this is just using 2.5 as a division is confusing to you, you can just do it a different way. That's fine, as long as your line looks like it has the correct steepness and the correct direction. All right, so there you go. Now notice I wrote a full line. The reason I wrote a full line is because it's greater than or equal to. Now at this point we have to use a test point. So I'm going to use the purple for that. I'm going to try 0, 0. That's always a good number to choose, or not always, but we have to choose a point that's nowhere near the line, because sometimes students accidentally choose a point that's too close to that line and it ends up being over to the other side of the line. So we could choose a point here, we could choose a point over here. I'm just choosing 0, 0 because it's usually easiest. So now we're going to do the test point. So let me show you how this works if you forgot. What we're going to do is we're going to test 0, 0. So that test point is 0, 0. So what that means is we're going to plug in 0 for x and 0 for y. This is not the same thing that we did over here. Over here we plugged in a value for x and then solved for y, or we plugged in a value for y and solved for x. But in this case, we're going to plug in an x and a y and just see if it works in the inequality. So it's a little different. But in both these situations, we were using this equation. So -4, I'm just going to copy that inequality down, but instead of y, I'm going to write 0, and instead of x, I'm going to write 0. So I just plugged in our x and our y value, and our x value is 0 and our y value is 0. So now we're going to simplify and see if that inequality statement is true. If it's true, we're going to shade in this part, the part that the point is on. But if it's not true, we're going to shade in the other part. So let's see if this inequality is true. So -2 times 0 is 0. So we have -4 minus 0 is less than or equal to, and 0 plus 1 is just 1. And -4 minus 0 is just -4. And so we have -4 is greater than or equal to 1. So you tell me, is that true? Is that a true statement? Is -4 greater than or equal to 1? And the answer is absolutely not. -4 cannot be greater than 1. So that means we're not going to shade in the region the point is on. We're going to shade in the region on the other side of the line. So just be aware, this doesn't have to be perfect, but just try your best to shade in there. In fact, let me just give you an idea what I require. So if you shade in like that, that's fine. It doesn't have to be the whole area. All right, so that's the answer for number 24. And I forgot to write the points in. Again, you don't have to show the points on the graph, but I'm just going to do it. And let's see here. All right, that's it. So we got one more problem. So same thing, we're just going to draw our axes. And this is a linear inequality, so we have to plot 2 points and connect the dots, just like we did in the other three problems. Now this is going to be an easy one because look how simple this inequality is. Oh, I forgot to write my other point in the table here. All right, so for the first point, we'll just choose 0 for x. And we can see pretty clearly that if x is 0, y must be 0 too. So that point's going to be 0, 0. Let's choose 1 for x. If x is 1, then you can see that y is going to be 1 too. So we just get 1, 1. So this is a really easy one. So 0, 0 is going to be here. And then we can just make one division. And then 1, 1 is going to be here. Then we just connect the dots. Now when you connect the dots, I just realized we have to put a dotted line. So don't put a full line. I almost put a full line there. All right, so that's our dotted line. And by the way, I didn't mention, be sure to fill your entire window. This is your window. A lot of students they'll fall short. They'll just fill in between the dots, or they'll fill in a short line. It's got to go all the way to the edges of your window. All right, so at this point, we just have to do a test point. So we can't choose the origin. We can't choose 0, 0 like we did in the previous problem because that's actually on the line. We have to choose a point that's far from the line. So let's choose 0, 1. 0, 1. And we just plug that in. So so that means y is 1 and x is 0. So is it true that 1 is greater than 0? And obviously that is true. So that because we plugged in this point and it was true, that means we shade in the side of the line that the point is on. And there you go. So that's the answer. And again, the dotted line means that the points on the line do not work in this inequality here. All right, so that was your first practice test for test number 4. And so, in my opinion, this test is probably more difficult than the other tests that we've done in this class. So it's a little bit more difficult, but I think the test I'm going to actually give you is going to be a little easier than what we just did, so just be aware of that. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for the test, go ahead and do that. Now let's look at the homework. As I mentioned before, the homework is a practice test. So go ahead and get a screenshot of those first 2 pages. And the 3rd and 4th page. And the 5th and 6th page. And the last 2 pages. But don't forget, you need to get a screenshot of the answers. So here's the answers. Go ahead and get a screenshot of that. And remember, you need to study for test number 4. Don't take that test unless you are prepared for it. And remember, if you don't do that homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.